Geo presents Limits. An introduction. First, let's look at a graph of f. As the function gets infinitely close to some value of x, say x gets closer and closer to 3, from both the left and the right, we say that the limit is the y value that the function looks like it wants to be. In this case, 10. But, really important, the limit does not care what happens exactly at the x value of 3. F of 3 does not matter to the limit. More about this soon. Here's a more mathematical description of a limit. As x values get infinitely close to some number, the limit of the function is the y value that the function gets infinitely close to. Let's see some other examples of limits. Estimate the limit of f as x approaches 5. We need to get infinitely close to 5 from both sides, from the left and from the right. Closer. Even closer. Still closer. Closer. So it seems the limit of f as x approaches 5 is 2, because the limit from the left and the limit from the right both look like they will be about 2. But remember, f of 5 does not matter. F of 5 could be 2. F of 5 could not even exist, a hole. And the limit is still 2. F of 5 could jump to 4.5. But the limit is still 2. Writing limits with math language. We can write about limits much easier using math notation. If we say, as x approaches 5, the limit of the function f is 2, or the limit of the function f as x approaches 5 is 2, same thing, we write LIM, abbreviation for limit. Limit as x approaches 5 is shown underneath the LIM of f of x is 2. Left and right limits. For a limit to exist, the limit from the left must equal the limit from the right. We write a limit from the left, from the negative side, like this. Right, Geo, the negative sign is not an exponent. We write a limit from the right, from the positive side, like this. Still right, not an exponent. So, when we write limit as x goes to 3 of f of x equals 10, it means the limit from the negative side of f of x coming from the negative side is the same as the limit coming from the positive side, and both have the same value, 10 in this case. Again, because for a limit to exist, the limit from the left must equal the limit from the right. Another example. Let's estimate the limit of g as x approaches 5. Get closer. And closer. And closer still. Whoa. It seems like the limit from the left of f of x is about 2, and the limit from the right, from the positive side, is about 3.6. So the limit as x goes to 5 of f of x does not exist. Oh. Again, f of 5 could be anything. It does not matter for the limit. F of 5 could equal 2. And since the limit from the left and the limit from the right are different, f of 5 does not exist. F of 5 could be 3.6, and the limit does not exist. The value of the function at 5 could be 3, somewhere in the middle of the two, but the limit still does not exist. F of 5 could equal 5.8, the limit does not exist. F of 5 could be any value, and the limit does not exist. And f of 5 may not exist, and the limit does not exist. This does not, remember, have to do with the fact that f of 5 doesn't exist. It simply means that the limit from the left and the limit from the right are not the same. Vertical asymptotes and limits. Remember, infinity is not a number. So if a function zooms up or down, as it does near a vertical asymptote at x equal a, we say that the limit does not exist, and we write the limit as x goes to a of f of x does not exist, dne. If the left and the right limits both go up toward positive infinity, we can add the symbol plus infinity and write limit as x goes to a of f of x does not exist, in parentheses, then positive infinity. Or if they both go down, we can add negative infinity. Sometimes people write limit as x goes to a of f of x equals positive infinity, or if both sides go down, negative infinity. Oh, this is not technically correct. It's okay on the AP exam, but if the left and the right sides go in opposite directions, we can't even use infinity. And we just write limit as x goes to a of f of x does not exist. Coming up soon, limits at infinity or towards infinity, limits from equations, and that's it for now.